Okay, so let's start. Hello and welcome everyone on this fine Wednesday evening. My name is Przemek Saracen and I will be your host for today. I've been with Kobiro since its beginning in Warsaw. I'm a senior PHP developer here, and I'm a kind of a resident Pact expert here. And we thought I would share some of my knowledge with you. This presentation will be a first in a series of presentations about Pact, about contract testing with Pact. And the presentation today will be more of a bird's eye view introduction before we take a deeper dive in further presentations of the series. So today we will talk more about the basics, definitions, theory, etc. So let's get to it. Before we start, if you would like to post some questions to me, well, there will be time for questions at the end of the presentation, but if you have some during it, please use this link. I will even paste it into the chat, so we will not interrupt the flow of the presentation. Also, full disclosure, I'm not wearing my headphones right now, so I won't be able to hear you. But I will answer your questions later. So here we go. So what you will learn about today? Well, we will talk about contract testing, some theory behind it, and how it can be done, how it can improve your overall experience, what is Pact, and how it is used to do contract testing, how do we use this tool, and also what benefits can we gain by using Pact in our contract testing. So let's go. Let's start with the contract testing itself. Before we begin, I would like to tell you that I would like to simplify the whole process, and let's talk about only REST HTTP APIs at the moment, because it will provide for a simpler understanding of this whole process. So when we have a REST API interaction, we will have two parties to this interaction. Those two parties can be named provider and the consumer. The provider will be the API itself. For example, it will be a microservice which exposes some HTTP REST endpoints. The consumer, represented here by a popular browser's icon, will be another party, for example, an application which uses this API. So it will be basically an API client. Those two sides interacting with each other can describe those interactions. For example, you've seen in your whole life probably some API documentations, and those API documentations are basically contracts. They describe the API from the provider side. The consumer can also describe the API. For example, for a team of front-end developers can describe by ways of, I don't know, a Jira task or something to the backend developers what they would like to interact with on the backend side. What endpoints do they require? Those are contracts. And having those contracts can improve our overall developer experience, because if we know what both sides desire of the API, we can test them basically in isolation, because we don't need those sides to be present. We will only need a tool to check if both sides of the contract have the same understanding of the contract. And that's the whole purpose of contract-driven testing. So I would like to talk about some tools we can use to do contract-driven testing. This is not by any means an exhaustive list of tools. Those are only the tools I have my personal experience in using and can talk about how to use them, what are the downsides and upsides of them. There are probably more and better tools, but those are, as I said, the tools I have my personal experience with. So the first tool we can talk about is Swagger CodeGen. For those who don't know this tool, this is basically a library which generates SDKs based on API documentations written in OpenAPI standard. We can use those SDKs to automate our testing process. But doing it like this has some downsides. Well, the obvious one is that this tool wasn't designed for contract testing. So we'll have to do some coding beforehand to adapt it to be used to do contract testing. Also, it requires the OpenAPI documentation to be written correctly. And that's not always the case. Even if the API documentation is generated based on some annotations or something like this, we don't really know if it's really all up to date and 100% compatible with the API. And also it has another downside, which I can talk about describing the second tool. The second tool is Postman. Postman is a wonderful app which helps us write documentation for the API and to test it. It also provides some test assertions, and by combining those test assertions and the Newman command line tool, we can also automate the process of testing with Postman. But even if we, for example, have thoroughly tested the provider side of the API, this process is still not bulletproof, because we probably don't know if the consumer side really uses the API itself properly. We have no way to check that. So enter Pact. Pact makes all this process, can make this whole process automated, but it also eliminates the handcrafting of the contracts. How it is done? Well, let's get into it and talk about Pact itself. So what is Pact? Pact is basically a set of tools. I will talk briefly about those tools, and we will have a deeper dive into them later. But for the sake of defining what they do, we have the mock server. The mock server will be representing the provider side for the consumer. How does it work? We'll talk about it a bit later. The Pact broker is basically a standard of storing the contracts. Contracts, also known as pacts, in Pact meaning they will be a set of simple JSON files. The Pact broker client is a library which allows us to communicate with the Pact broker. Also, we have the Pact provider verifier. This is a library for the provider side. It's used to verify contracts downloaded from the Pact broker. Also, all those tools are distributed as binaries or Docker containers, if that's what we prefer to use, and also some language-specific libraries. So there is a Pact Foundation library for PHP. There is also one for JavaScript, etc. So we can use Pact with basically any programming language which is supported. I would like to also take a minute and talk about Pact Flow. As I've said before, Pact Broker is a standard, and Pact Flow is an implementation of the Pact Broker standard. This is a commercial implementation, but it's made by the Pact Foundation, the creators of Pact itself. And we use it at Cobiro. It's a nice tool because it has a web interface. We can use this web interface to browse our contracts, which can serve as basically an API documentation. So we can browse our contracts, browse interactions which belong to these contracts, browse their different versions. It also can throw us a microservice diagram. This intimidating looking diagram is a diagram of our microservices at Cobiro and also outside dependencies, but fear not, you can disable some of them to make the diagram more readable. And also you can use the Pact Flow to create some webhooks. For example, if you'd like to be notified on some actions that are performed on the Pact Broker, like publishing the contracts, verifying or failing verifications, you can define some webhooks. For example, if you would like to be notified on Slack or by email or something like that. So that's where the Pact Flow shines. Okay, so how contract testing in Pact is done. Contract testing in Pact is consumer-driven. So the consumer is the source of truth. The consumer defines the contract. This is done in such a way that the consumer development team writes some API tests, integration tests. Then the Pact consumer library, based on those tests, produces a contract. A contract, as I said before, it will be a set of JSON files. Those JSON files are then published to the Pact Broker. And that's the consumer side. If the tests pass and the contract is successfully published to the broker, the consumer is done. Then the ball is in the provider's park. So what happens on the provider side? We have this library I've mentioned before, Pact Verifier. Pact Verifier downloads the contract and verifies it using an instance of the provider application. It interacts with it. So it takes every interaction, every request, and runs it against the provider. Then it checks if the responses to those requests match those defined in the contract. Regardless if they match or not, after the verification process, the verification status is published to the broker. And that's basically how it theoretically works. There is also one small little caveat, and that some interactions will require the provider to be in a specific state. For example, if you would like to get details of a product with ID of 1, it will require the product to exist in the provider. We can think about it as the given clause if we describe our tests in the Gherkin language. And this given clause is represented by something called provider state. The provider state is set up by the verifier on the provider and can be used as a given clause for tests. This is looks simple on the outside, but it's such a complex problem and can be used to achieve some really complicated and wonderful results that I would like to make a separate presentation on the provider state itself. So I just wanted to mention that thing like this exists. So What's next? I've mentioned that the contract is generated by writing the tests itself, but how is it done? Well, let's talk about one of the greatest upsides for using contract-driven testing. As I said before, the consumer generates its site and it's done. It doesn't need the provider, and also the provider doesn't need the consumer. So we test both of these sites in isolation. So we won't need the provider to do our integration tests. We won't need an instance of the provider. The provider will be represented by the previously mentioned mock server. The mock server will take the place of the provider during our integration tests. So how does the flow look like? We begin writing our test, our integration test, by describing the expected interaction to the mock server. So we describe what request we will be performing and what response we would like to receive from the mock server. Then we run our test. The code under testing will perform the interaction. So it will make a request to the mock server. The mock server will then validate the interaction. So it will check if it was actually expecting this interaction, this request to an endpoint. Then it will check if the request data for headers, maybe the body, etc., matches the expectations set previously. Regardless of this, it will return a response. If the interaction was validated correctly, the response returned will be the same one defined here. If the validation process fails, it will return an error response. It will return status code 500, internal server error, and it will also return a list of errors it encountered during the validation process. We can then run our assertions on the test. One of them, for example, can be asserting the status code of the response. So if it's 500, we've obviously failed this, so the test will also fail. One thing it's not present in this diagram, that after all of the tests like this are done, when the mock server shuts down, it will also check if all the expected interactions are performed. If they are not, the whole testing process will fail, regardless if all the tests have passed. And also the mock server will generate contracts, JSON files, based on those interactions. So that was the theory. Let's see some code. The code I will present to you will be a sneak peek because we essentially don't have time today to do some more deep diving, thorough examination of it, but I can show you some examples and tell you how it basically works and looks like. So the first example is taken straight from the Pact library. This is using the Pact Foundation PHP library. And I will describe how do we present an interaction to the mock server. So the first thing we need will be a request. So we can use the consumer request class to define what request would the mock server expect. So we set the method of the request, we set the path, we can add some headers, we can also add a body to the request, but in this case it is a simple GET request, so we won't need it here. The second thing we will need is the expected response. So we can also define it basically like in the same way. We use the provider response class. We can set the status. which will be returned. We can also add some headers, and we can set the body of the response. Here is another caveat. We are using the matcher class here to provide the provider with some leeway. What I mean by this is what we are doing here. We are not only telling the mock server what interactions it will have to expect, but also we are defining the whole contract here. So we not only define this interaction, but basically a set of interactions that will match this contract. So we are using the regex clause here. So if the provider responds with something matching a regular expression like this, the response will be valid. So hello Bob, but also hello Alice will be valid responses in context of this contract. The first argument here is the example. It will be displayed in the documentation, and it will also be used by the mock server to return its response. After defining the request and response, we use the interaction builder class to inform our mock server to use this interaction. So here we set up a given clause. This is the provider state I've previously talked about. This is not needed. This is an optional step, but we can define it regardless. In this case, we tell the provider that a person must exist, whatever that means. And we tell the mock server that upon receiving this interaction, this is only a description, but those descriptions must be unique within a contract. And we tell it that if we encounter this request, we will have to respond with this response. This is the same, but using our own library. We found some deficiencies, mostly in developer experience, with the Pact PHP library. So we are currently in the process of writing our own one, which will essentially be a PHP unit extension using Pact. And I will show you how it's done using this library. It's not open source yet, but after it matures a bit, we would like to take it open source. So in this case, we have a collection of mock servers. We get a mock server instance, and we can seed it with an interaction. So we can define a request and response, like previously. Also, in this case, it doesn't need to use the custom consumer request and provider response classes. Those can be any implementations of the PSR standard of request and response based communication. So again, we set up a simple request, we set up a simple response, and that's basically it. Now the mock server knows what will it expect. So in this part, which is represented by this comment here because it won't fit in the slide, we will run the test itself. So we will execute our code, which will underneath communicate with the provider, and then we can do assertions. After running this test, the contract will be generated automatically and saved in a chosen directory within our project. How to set all this up, I will talk about in the next presentation, in which we will delve deeper into writing our own code. So after we have our contracts, we can publish them. I think preferred way to publish the contracts will be by using the Pact CLI container. It has some nice tools for it. Basically, we are using the publish command We set up some environment variables to know the broker URI, the broker token, etc. And this command will publish our contract, which is stored in the Pacts directory, in this example, to the broker. After publishing the contract, we will have to verify it. I would also like to do a separate big presentation on verifying contracts. So this is also a bit of a sneak peek. This is how we can set up contract verification using continuous integration. And in this case, it's using Circle CI because we use Circle CI here in Cobiro. Of course, a copy of this presentation will be provided to you offline, so you can read into it at your own time. But the most important piece of code here, it's the last line here. This is what essentially performs the verification. It's a one command, one shell script, which runs the whole process. It runs the Pact verifier, which automatically downloads the pacts and uses a previously set up here provider instance to verify the contracts. Okay, so that's how it looks like. And I would like to talk about some benefits of using Pacts like previously described. So the main upside, in my opinion, is that we run our tests in complete isolation. So as previously I told you, we use the mock servers only. We don't need to interact with any outside services. So it basically destroys the need of needing some development servers we would have to interact with, sandboxes, etc. I've returned to this complicated diagram, and think about if you would have to implement integration testing, which will use most of those services. If you would like to set up an environment locally, including all those microservices, it will be a really big pain in the butt. So that's when Pact shines, in my opinion. That we don't need those. And if we configure Pact properly, if we configure our contracts properly, it will all be available out of the box. You check out your repository code and you run your tests, and all those mock servers will be set up automatically. No need for configuring any outside services. So the contracts are generated automatically, which is nice, and we can use them as documentation. There's also a screenshot of our Pact broker. We can see some interactions. We can see some of them are verified, and we can see that 2 of them were not verified. So, for example, something has changed, and we have to look into it. What happened? Why are those interactions not compatible? And also, we can be informed during building if there is a contract mismatch. There's an example of a screenshot from Circle CI. This is a message from the provider verifier that we got HTTP status 401 instead of the expected 201. So basically we have an authentication error, and the whole interaction will be now marked as not verified. We can also, as previously mentioned, use some webhooks to be informed about this. So we are nearing the end of the presentation. So let's sum up what have we learned today. So we've learned about contract testing and how can it be implemented by different tools, but mostly Pact. We only got a sneak peek into it, but we will build up on it in later presentations in details. We learned about Pact a bit, learned about the tools it contains, how can we use it, what's its place in contract testing. We've learned a bit about Pact flow and how it can improve our developer experience. And also we've learned about some gains, some upsides of using Pact. But what have we not learned? What we will learn in the future? Basically, what I've told you before, we will learn about how to use PHP libraries to write our own consumer contracts. That will be the one big presentation, and another one will be about verifying them. And also we will use the Pact Foundation library, and also when our Cobiro edition library gains the status of an open source library, we'll learn about using it also. We will learn, as previously mentioned, about how to use provider states. There's a complex problem because the example I've used before was basically about seeding database, but we can do much more. We can basically seed, if that's the proper word, more mock servers. If we have some complex interactions that require performing requests onto not one microservice, but to a whole network of them, we can use the provider state to set all of this up. I've just learned that you were not able to ask questions. Please forgive me and bear with me on this. Now it will be available to you. So if you would like to ask questions, please do it right now. Thank you and sorry for the inconvenience. Okay, so next we will learn about how to set up continuous integration using different tools. So basically how to set up the whole flow I've described, the whole process of running tests, generating contracts, uploading them to the Pact broker, downloading them from the broker, verifying the contracts, etc. We will also learn excuse me a bit, I don't know what happened. Okay, so for some reason the presentation crashed on me. And okay, going back, we've learned about using Pact on front end. Basically, we will learn how to write the same thing I've talked about in PHP, but we'll learn how to do it in Angular. We will also learn about versioning of our interactions. This is something I didn't mention before, but basically, mostly our consumers and our providers can have different versions of the application, the API, and sometimes they will be compatible with each other, sometimes they won't. We can use the Pact broker to determine which versions of the applications are compatible with each other. So we will learn about it at a later date. And also, a big part of how Pact is a wonderful tool is that it can be used to contract test not only HTTP-based communication, but whole lots more. For example, in microservice architecture, we mostly communicate using queues like RabbitMQ or Kafka or something like that. And Pact also provides tools to facilitate contract testing of these kinds of communication. Okay, so that will be the end. I apologize for the technical problems. Always Murphy's law dictates that they will happen at the main presentation. You can see some addresses on how to contact us. Łukasz is a manager here in Kobiro. Przemek, that's me. We are hiring, so if you'd like to work with us, or you've been interested in contract testing and you would like to write some contract tests yourselves, you can write Oscar, and well, we will be welcoming. So also we have a small surprise for you, sponsored by Pact Foundation. If you go to pactflow.io, you can increase the contract limit from the usual 5 to 10 using Warsaw Codecraft code, and use it when starting up for the starter plan. So thank you. That was all I would like to present. Now I'm putting my headphones back on, and I would like to answer your questions. So firstly, I'll see the questions from the presentations. I was asked to present the code. Okay, so let's see those questions. Mieszko, how do you handle situations where there are several clients and may have conflicting expectations? Well, basically, several separate clients have separate contracts. So we don't reuse contracts for different clients, because the client is the source of the expectation. And, you know, if you would like to do this process correctly, the provider will have to conform to any expectation. So if one consumer wants this and another wants this, the provider will have to conform to both of them. But, you know, that's the theory. We can use also outside tools to communicate, right? And you know, it's not written in stone that we'll have to 100% conform to it. We can negotiate, right? I don't know if that answers your question 100%, but you know, there is some room for flexibility. Also, we can use versioning if that will solve the problem. So there are multiple solutions, but the most obvious one is that the contracts are separate. So contract between one consumer and the provider and another consumer with the provider should be considered separately. Okay, so another one. What if we have cache enabled using HTTP headers like cache control private? Is the Pact ignoring them, or is it able to test it as well? Good question. And well, it can be answered in different ways. One thing I can think of, one solution I can think about it is that we can simulate those headers. But I don't know if that will be the proper case. please bear with me, and I will answer your question offline when I have a more thorough answer. So if you'd like to, I would get your email and I will email you the proper answer for it. Okay. Is it possible to use Open API specs in integration testing, e.g. for generating code? I think yes, but I personally didn't do it. So I don't have a out-of-the-box solution for this. But it's a nice thought. Probably it will be available. Okay, in Cobiro, do you use also other levels of tests like integration or end-to-end? Does Pact mocks can be helpful here as well? Well, we use Pact mostly for integration testing, but we use them in separation of each other. And yes, we use them also for end-to-end testing, but it's not really end-to-end testing because we are using mocks here. So yeah, we are using Pact exclusively to do integration tests, but as I said, we use the whole process of contract testing. So one side defines the expectations, the consumer side. It tests itself using those expectations. Then the provider side gets the contract and tests itself based on those expectations. If both of those sides tested successfully, we assume the communication is tested. So that's the level of what we are doing. I don't think the Pact will be a proper tool for the end-to-end testing, like using the real live instances of the applications. It's not for it. It's not the proper tool for it. Okay, so does anyone have other questions? If not, thank you for your time, and we will be posting the next steps, the next episodes of our adventure in Pact. You will be all informed about it using the Meetup application. And so thank you. Have a wonderful evening. And Kacper, I will write to you personally with the answer to your question. Thank you.